Today's lesson is 5.5, Inequalities in One Triangle. We're going to start on page 295. The objectives are to identify the longest and shortest side of a triangle and also to use the triangle inequality. So we have several theorems in this lesson. The first theorem is theorem 5.10. If one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So for instance, if we look at triangle ABC, we notice that BC is longer than AB. So that means that angle A, because it's opposite of the longer side, angle A is greater than angle C, because angle C is opposite the shorter side. So angle A is longer than angle C. And theorem 5.11 says basically the opposite of theorem 5.1. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So in triangle DEF, we notice that angle D is 60 degrees and angle E is 40 degrees. So that means that the side that's opposite of angle D, which is EF, is greater than the side that's opposite of angle E, which is DF. So EF is greater than DF. So theorem 5.12 says, it's the exterior angle inequality theorem, and it says that the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent interior angles. So looking at triangle ABC, the exterior angle here is angle 1. And the measure of angle 1 is greater than the measure of angle A, because angle A is not adjacent to, remember adjacent would be right next to, so ACB would be adjacent, but angle A is not adjacent. So angle 1 is greater than the measure of angle A, and angle 1 is also greater than the measure of angle B. Now if you remember back from a previous chapter, remember the measure of angle 1 is equal to the measure of angle A plus B. So that means that definitely angle 1 has to be greater than either one of those angles by themselves. See, since the measure of angle 1 is equal to the measure of angle A plus B. Okay, the last theorem for this lesson is theorem 5.13. That's the triangle inequality theorem, and that just says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So that means that the measure of AC plus the measure of AB is going to be greater than that third side, BC. And also AB plus BC is going to be greater than AC. So it doesn't matter which two sides you use. If you add two sides of a triangle together, it's always greater than the third side. Okay, let's start with some example problems. On page 298 to 301, numbers 8, 10, 14, 24, and 26. Looking at number 8, we're supposed to identify the longest and shortest side of triangle JKL. Well, remember that the longest side is going to be opposite the largest angle. The first thing I want to do is find angle J, and because angle K is 90 degrees and angle H is 35 degrees, that's 125 degrees, so that means angle J has to be 55 degrees. So the longest side is the one opposite of the largest angle. So the longest side is going to be JH. The shortest side is that one that's opposite the smallest angle, and the smallest angle is 35, so the side that's opposite of that is JK, or KJ. Number 10 is just like that, except we're wanting to find the largest angle and the smallest angle. Well, our largest side is 10, So the angle that's opposite of that is angle Q. So angle Q is the largest angle. And then the smallest angle is going to be the one that's opposite the smallest side. The smallest side is 6. So that makes angle R the smallest angle. Okay, on number 14, we're supposed to list the sides in order from least to greatest. So my least, the smallest side is going to be the one opposite the smallest angle. So the smallest side is going to be AB. And then the next smallest angle is 60 degrees, so the side that's opposite of that is going to be BC. And then the largest side is angle B, or the largest angle is angle B, so the side opposite of that is AC. So that's the list in order from least to greatest. Okay, so now let's take a look at number 24. Number 24 says to solve the inequality AB plus AC is greater than BC. So in the drawing, AB is x plus 2, and AC is x plus 3, and I'm going to add those two together, and it should be greater than BC, which is 3x minus 2. So I'm going to add my like terms, so I've got 2x plus 5 should be greater than 3x minus 2. So if I move my like terms together, I've got 2x plus negative 3x is greater than negative 5 minus 2. So that's negative 1x is greater than negative 7. Divide both sides by negative 1. So x is less than 7. Remember, if you divide or multiply by a negative on an inequality, you have to turn that inequality around. So the answer here, the value of x that makes this true, is x is less than 7. So remember, this works because two sides of a triangle added together are always greater than the third side. So the last question we want to look at is number 26. Number 26 says, suppose you're walking south along Pine Street, so I'll be walking this way. And when I get to Pleasant Street, I cut across the empty lot all the way to the corner of Union and Oak Hill. Explain why this route is shorter than staying on the sidewalks. So if I stayed on the sidewalks, I'd go down Pleasant and then down Oak Hill and end up at the same corner. So why is that diagonal distance shorter than staying on the sidewalks? Well, this has to go back to one of our theorems here, and that theorem is the triangle inequality theorem. So the reason this is shorter is because Pleasant Street plus Oak Hill Street, since those together, when I would walk both of those distances together, so Pleasant Street plus Oak Hill is definitely going to be greater than walking across the lot. So the lot would be shorter than or less than walking Pleasant plus Oak Hill. So that's theorem 5.13. So your homework is page 298 to 301, numbers 7 to 19 odd, number 25, number 47, and number 49.